Everybody, this is Mr. Collins again. So we're going to now tackle solving overlapping triangles. Right. So much in the same way you just saw in the last section, we're gonna have to recognize one that we do have two triangles here. That's a big thing. But then two, we're going to have to force ourselves to see the proportionality of sides. In all these cases, we have to recognize that we do have two triangles. We have this smaller one kind of up top, and then that is laying on top of a larger one. And that's why I'm calling them overlapping, right? Because it's the small one is kind of sitting on top of the large one, and they're sharing one of the angles. I don't want to say top angle, because if I put it like this, the angle they share is actually on the side. Here's on the bottom. Here, the rest of them, they're on the top, right? So there's some variation there. But you should probably pause the video if you're not quite sure what I mean when I say, hey, there are two triangles here, because that's going to probably be the most confusing part. And so maybe just contemplate and force yourself to see that there's one triangle here that's laying on top of the larger triangle here. The reason why that realization is important is because that's going to lead to our main strategy, which is to redraw these triangles into two separate triangles. Okay. And so that can give us a better sense of what the side lengths really are, one, and then two, how to set up proportions to solve. Because these problems not only comprise a very large portion of your test, but they're also the ones that most people miss because they're not willing to do that redrawing step, if that makes sense, right? So let's just get into it. Let me zoom way in here because I'm going to need, there we go, about right there, I think, because I have to do kind of quite a bit of redrawing. All right. So now when I say redrawing, here's what I mean. Here we have the small red triangle, and so I'm going to kind of draw it right here. Okay, and then overlaps this larger pink triangle, which I'm going to draw right here. Okay. If I look at the small triangle on the left, I have x plus 2. Okay. On the left, I don't have 8, and it's not 5 either, because 5 goes from the bottom to right here where the E is, and then 8 goes from the bottom to the very top. Well, if the entire length is 8 and the bottom portion is 5, that leaves this portion to be 3. Okay? And that right there is a tricky part of these problems, is that hey, that 3 was never on the diagram, but it's implied that you have to be able to determine the length, in this case by subtracting. Okay? For the larger pink triangle, same thing. I know this side is 8 because it's just gave me 8, it's the entire length, right? But on the left, it's not x plus 2 and it's not 6. X plus 2 only goes for the top portion, and then you have 6 for the bottom portion. If you want the whole thing, you got to add it. X plus 2 plus 6 gives x plus 8. Okay? And again, that's the tricky part of these problems, is they're trying to get you to not to skip that part of the thinking. But once you're out of that thinking, we can see a direct correspondence. We have 3 over 8, so small triangle to large triangle. And again, you could have gone the other way. You could have made it 8 over 3. But that's just the way I saw it first, so small triangle over large triangle. Okay, and that should be equal to the same relative ratio, but on the other side. So we have x plus 2, x plus 8. Small triangle on top, that's going to be x plus 2. Large triangle on bottom, that's going to be x plus 8. And so now this should look extremely familiar compared to what you have done on the previous page. Okay, let me scroll down just a touch here. If my computer will let me, it's acting real weird. See how it's pulling? I have no idea why it's doing that. Anyway. All right, so we have 3 times the quantity x plus 8 is equal to 8 times the quantity x plus 2. Okay? So I'm going to resume the problem right here because I'm out of space. We're going to do some distribution, so 8x, plus 16 is the same as 3x plus 24. All right, so let's do some moving around. So let's subtract the 3 x's on both sides to move them to the left. At the same time, we'll subtract 16 to move those to the right. We're just doing 2 steps of algebra, 1 step to save some room. So we have 5 x's because those cancel. 24 minus 16, I believe, is 8. 24 minus 16, yeah, it's 8. Okay, and so now we just divide both sides by 5. 8 divided by 5 gives me 1.6. Okay, Now we can go back to our ratios to solve that out. I don't have any room to do it on screen, but I'll talk through it. 3 divided by 8 is 0.375. Okay, so if I divide those, that's what I get. If I take 1.6 plus 2, I get 3.6, and I'll divide that by 9.6 on the bottom, and I also get 0.375. Okay, so even if you get like a weird decimal answer, you should have confidence that you're doing it right, like you did the right things. It's just showing you the diversity of all the different types of answers and work that we can have. All right, so let's slide that over and look at question 2. All right, and we're going to approach this much the same way. If I can get my computer to stop freaking out on me. All right, so it seems like in the first example we can redraw the triangles and then relabel it. I think we should do the same thing here. So we have kind of a small triangle on top. That'll give me 8 and 6. Okay, and that overlaps a large triangle. Okay, on the left, it's not just 8, it's not just 10. 8 takes care of one portion, 10 on the other. That gives me 18 for that entire side length. And then again, we have 6 to be part of it, 8 to be the other part, and so we have x plus 6. Well, watching you guys work, I saw a lot of people make this side 6x. Remember, you're adding here, not multiplying. And so x, it should be x plus 6, not x times 6. That's a very easy mistake to make. Okay, now we're in our solving steps. Okay, so we have 8 and 18. So if I take 18 over 8, that establishes large triangle on top, small triangle on bottom, which means I have to match that for the other side. So large triangle on top, x plus 6, and then 6 on bottom for the small triangle that corresponds. So we have left side large over left side small is equal to right side large over right side small. Now we can go into the cross multiplying / solving steps, which hopefully is getting a little repetitive, but that's on purpose. So we have 18 times 6 is going to be 108. Okay, and that's going to be 8 times the quantity x plus 6 crossing the other way. Alright, so that'll give us 8x plus 64. Remember, because we have to distribute the 8 to both parts, is equal to 108. Okay. Okay. So we subtract 64 on both sides. So 108 minus 64 gives us 44. Divide both sides by 8, and we get 5.5. All right, let's move on to example number 3. And so hopefully the strategy is becoming a little straightforward and fairly obvious. Okay, we have our small triangle, x on the left, 5 on the right. Then we have a large green triangle. We have x plus 16 on the left, and then 15 on the right, because I'm adding the two partial side lengths. All right, so left is to left, so x over x plus 16, that's small to large, is equal to 5 over 15. Okay, now I can see that the ratio top to bottom is 3, because 5 times 3 is of course 15. But like that doesn't really help me with the x's. I mean, technically, could we set up an equation? Yeah, we absolutely could. But honestly, I think the best strategy here is still just to cross multiply. So we have 15x on one side. Okay, so 5 times the quantity x plus 16 on the right. So distributing 5 times x, 5 times 16, that gives me plus 80. Okay, we'll subtract 5x's on both sides. So we end up with 80 is equal to 10x. So minus 5x minus 5x, which implies x has to be equal to 8 because 10 times x is 80. Okay, now remember the big important step in this problem The first two important steps, I think, are right here. If you can get to that, if you can separate the triangles and get to the proportion, you're gonna be successful 9 out of 10 times. Right? Let's look at this guy. Alright, so womp, womp, womp. Okay, so we have 12 on bottom, like that makes sense. And then we have x plus 5 on top. Okay, so the big triangle that's overlapped. So on the bottom we have 8 and 12 together, that makes 20. Here we have x plus 5. Well, x plus x is going to be 2 x's, and then the plus 5 is not a like term, so we can write that like that. Okay, so bottom is to bottom, right? So 12 is to 20. Okay, so small triangle over large triangles are ordered. Is equal to top and top. Small triangle goes on top. That's getting real messy. Okay, so small triangle on top, that's going to be x plus 5. Large triangle on bottom, 2x plus 5. So we see we're creating these opportunities for distribution. Okay, so let's cross it up. Maybe I think I'm probably writing too fast, the board's just not keeping up. So 20x plus 5, here we go. All right, so distribution, both sides. So 20x plus 100 is the same as 24x plus 60. 12 times 5 is 60. All right, so let's kick the 20x's to the right. And simultaneously, let's kick the 60 to the left. Uh-oh, run away. I don't know what's happening. Come back, stop it. Okay. So those are canceled. 40. 24 x's take away 20 x's gives me 4 x's. Okay, and so x is implied to be 10. All right, guys, I'm going to cut this into 2 different parts then, so I can see if I can fix my board, because it's just, I don't know what's going on. All right, so I'll stop this part here. Next, we'll do the next 4 problems in the next video, but it's going to be the same style. And so let me stop here and see you guys in a minute.